Good evening. My name is still Mr. David Glante. Today's lesson is going to be on states of matter. But before we proceed, I want to do some correction of something that I think I made an error somewhere here. I just want to rectify it. And then we can proceed. Let me see what, let me see. It was on, I think I said crystallization instead of sublimation. So I'm trying to locate, oh yeah, so this one should be sublimation instead of crystallization. That is sublimation. Okay, sublimation is used when one solid in a mixture can turn directly into gas without when heated. So that's sublimation. But I'll still talk about sublimation again when we talk about change of state, so you would appreciate what it is. So, like I said, today's lesson is going to be on states of matter. Let's go back to it. Yeah, so this is it. It's going to be on states of matter. Now, during the classification of matter, if you recall, I showed you this chart here. And so far, we have done everything under chemical classification. The whole of this has been treated. We've finished with the whole of this section. Okay, that's what we did previously. Today, our emphasis is going to be on the physical classification of solids, and that is going to be this one. Okay, okay. Now, we are going to look at what we call the kinetic theory of matter. The kinetic theory of matter. The kinetic theory of matter attempts to explain why substances exist as solids, liquids, and gases. What happens there? So we are going to look at the key aspects of the kinetic theory of matter. Now, there are so many variations. You can get different versions from a book. So this is just my summary. What you may find in a book might be different. Okay. But essentially, this is the most important one. The first thing is that all matter is made up of tiny particles. These particles could be atoms, they could be molecules, they could be ions. So that's very important. And then there are spaces between them. The second thing, the second aspect of the kinetic theory of matter is that the particles are constantly moving. If you don't want to use the word moving, another word is motion. They are in constant motion, means they are moving. And because they do not have eyes, they do not have brains, they bump into each other, they collide. So we use this word, collide. They collide with each other and the walls of the container. Now, it's also important to understand that these particles have different velocities. They don't move at the same speed or at the same velocity. Just like if someone were to throw a snake in your class, you start running. Some will be faster than others. So basically, the particles are like that. Some move faster, some are slow. So that's important. That's for this one. And then it's also important to understand that when you increase temperature, when you heat something, the particles move faster and farther apart. This is very important. And the final one under this subheading is this. And I want you to remember this because there's going to be a question where they will mention this. And even when you get to grade 12, I just taught them a topic called rates of chemical reaction. And this is important. If they ask you, what is temperature? You say temperature is the measure of the average kinetic energy of the particles. Now, any particle that is moving, that is in motion, has velocity. And if you have velocity, you have kinetic energy. In fact, you will learn very soon, or I think it's term 3 or term 4, you will learn that kinetic energy, EK, is equal to half mv squared. This m is mass, so these are constants. What is different is the velocity. This is the speed or the velocity. So anything that is moving has kinetic energy, and the kinetic energy is proportional to the velocity. In other words, When the velocity increases, the kinetic energy increases. So we are saying that the temperature of a substance is a measure of the average kinetic energy. When you take the kinetic energy of all the substances and divide them by the number of substances, then you get the average kinetic energy. This is very important. This definition, you should always remember that. Then we should also mention that when the particles are moving, in fact, you would also learn this in what we call Newton's law of universal gravitation. I think it's in grade 12, that there's always a force of attraction between any two bodies. Okay? Any two bodies have a force of attraction. It's a natural tendency. So the particles have mass, and therefore there will be some kind of attractive force between them. However, the attractive force is directly proportional to, but inversely proportional to the distance. If you don't want to use the word inversely proportional, what it simply means is that if the particles are close together, the force is great. If the particles are far apart, the force is weak. Basically, that is it. Then the last thing I want to mention, as far as the states of matter is concerned, I mean, the kinetic theory of matter is concerned, is this one. And I'm going to talk about it later in detail. And what it says is that the state of matter depends on the melting point and the boiling point. In other words, whether a substance is in the solid state, the liquid, or the gas state, it depends on what we call the melting point and the boiling point. So, like I said, I'm going to explain it at a later stage. So just accept it as it is. Now, it says that if the temperature is below the melting point, the object will remain, I mean, the material or the substance will remain as solid. Now, if the temperature is between the melting point and the boiling point, it will be a liquid. And if the temperature is above the boiling point, it will be a gas. This is important. There's going to be a question about that, and I want you to make sure you understand this. Now, we are going to look at the particle nature of matter. I'm going back to this, and then you'll see what I'm talking about. I started by saying that all matter is made up of tiny particles or particles. So what is the evidence? What is the proof? How do we know that indeed matter is made up of particles? Now, there are two sources of evidence. The first one is called Brownian motion. Now, this Brownian motion is named after a Scottish botanist. A botanist is someone who studies plants. So there was a botanist in, I think it was in 1827. That's about 200 years ago. In 1827, a Scottish botanist by name Robert Brown, he was studying or observing what we call pollen. Now, pollen, if you did your life sciences, you would have heard about pollen grains. That is the male gamete or the male sex organ. I mean, sex cell, not sex organ, sex cell. So what he did was that he observed it under a microscope by placing the pollen or suspending the pollen in water. And then he had light here. This is a source of light. So the light is like a torchlight, flashing the light into the so that he can use his microscope to see what is going on. Now, to his surprise, he saw that the pollen grains were moving, even though he wasn't shaking the table, even though there was no air or wind blowing, the particles of the pollen grains were moving. So that made him to conclude that um, the water or the medium in which he suspended the pollen grains actually had particles, and the particles were moving. And as they moved, they bumped into or they collide with the pollen grain, and therefore they caused the pollen grains to also move. So that is one evidence of the existence of particles in matter. Now, the second one is diffusion. You would have probably experienced this that sometimes when you're walking in town, maybe you are passing by KFC, even though you are not in the premises of the KFC, the smell alone, the aroma begins to attract you. How did the smell come from, or the aroma from the shop or the premises? How did it come outside to you? It came out or traveled to you by a process called diffusion. And diffusion is simply the movement of molecules or particles of substances from a region of high concentration to a region of low concentration. Now, diffusion increases with increase in temperature. It means that when it's very hot, um, you know, when it's very hot, diffusion, the rate of diffusion is greater. And also, if the particles are very big, the rate of diffusion is low. Let me just give you something. Maybe it's not a very good example, but it would be. If you've lived in a place where people use what we call an open latrine, some of you, if you're in a public school, you would have observed this, that the toilet smells bad during summer when the weather is hot because the temperature is hot, so the molecules or particles move faster. So you inhale the smell worse than if it is winter. So that is what this part explains. So this part is basically what I'm talking about. Now, so what is we are going to illustrate diffusion by looking at this diagram here. So where the source is, the source of the smell or whatever, we say there's a high concentration of particles or molecules. Now, the particles or molecules travel from a region of high concentration to a region of low concentration. So that is basically what diffusion is. Now, it's important to understand that diffusion occurs in fluids. When you say something is a fluid is either a liquid or a gas, okay? A liquid or a gas. So we can demonstrate diffusion in the laboratory by this experiment. You take droplets of something, a pigment or a dye, you put it in water. Over a period of time, it spreads throughout the dye. Another example, throughout the liquid. Another example is, when if you have taken a tea bag before, you prepare tea, you put it in, the tea bag in your teacup, you put your hot water inside, and then over time, even without stirring, the brown color would spread, and eventually your whole tea will be brown. So basically, this is it. So that is in a liquid. Now, you can also demonstrate diffusion in gases, and this is one of the what you are going to do. In this simple experiment, what is happening is that you have a brown gas here. It's called nitrogen dioxide. You put it in a container like this, you cover it, and then on top of it, you place an empty gas container, empty. Then in the next stage, you pull that cover away, you remove it. Over time, you see that this brown cover spreads until the whole thing becomes like this. So this is called diffusion. I think you would also do it in life sciences in grade 10, yes, as part of. So basically, that is it. Now we move quickly to what we call states of matter. Again, states of matter is something that you are familiar with. You did it in NS. We recognize three states of matter: solid, liquids, and gases. In fact, there are four states. The fourth one is called plasma, but you are not going to learn that in secondary school. If you make it to the university, you will learn about plasma. But at the secondary level, we have solids, liquids, and gases. Okay, and you are familiar with that. Now, if we look at the arrangement of particles, this is how a solid would look like. Particles are close together, they are packed like that. In a liquid, they are a bit separated. There are some spaces between them, much larger spaces between them. And then gases the particles are far apart. So this is a gas. Again, like I said, you did this in NS, so it shouldn't be a problem. Now, this is a very important table. This table compares solids, liquids, and gases. Oh, this is liquid. The spelling is wrong. Liquids. Okay, solids, liquids, and gases. So we are going to compare them under a number of criteria. The first one is the arrangement of particles. As I indicated before, with solids, the particles are compact, means they are closely packed. With liquids, they are not closely packed. The particles are able to move randomly. So we say there's no fixed pattern. In solids, the pattern is fixed, it is rigid. In a liquid, it's flexible, it moves like that. And then in gases too, you don't have a fixed pattern. So what happens in a liquid is similar to this. This information, they are basically the same thing. Then we come to the spaces between them. The spaces between the particles of a solid are very small because the particles are touching each other. So there is only very little space. Like I indicated here, let me come back here quickly. See, when I talk about spaces, I'm talking about the space, this spaces. See, the spaces are small here compared to the spaces here. And indeed, also the spaces here. So these are what we are talking about as far as spaces are concerned. Then we talk about shape. In terms of shape, we say that solids have a definite or fixed shape. It means the shape is fixed, okay? You can't change it easily. But with liquid or liquids, the shapes are not definite. You can say they are indefinite because they take the shape of the container. So depending on the container, the shape would adjust itself to suit the shape of the container. And gases also do not have a definite shape. Then we talk about volume. The volume of solids are fixed or definite. The volumes of liquids are definite, but the volume of gases are indefinite. They are not fixed. The normal gases just expand and fill whatever space that is provided it. Now, in terms of movement of particles, this one, talking about solids, we say the particles vibrate. What does vibration mean? Vibration, just look at the movement of, so if a particle is here, it moves like that. It moves over a short distance like that. We call that vibration. It doesn't leave one place for another. It just shakes from one point to other. We call that vibration. Now, with respect to a liquid, the particles slide over each other. They move and slide, they move and slide like that. And then with gases, the particles just move very fast, randomly. Now, in terms of density, the density, I mentioned density. Density is mass divided by volume. You remember I mentioned that divided by volume. So if the volume is small, the density is high. Now, most particles have small volume because they are all packed. They are grouped together in a small space. So the volume is small, and therefore the density is high. This one is medium, and this one is low. Then the final thing I want to talk about is compressibility. Compressing something is pressing it or squeezing it. Now, solids cannot be compressed. You can't press them because they're already touching each other. So if you press them, it means you are going to break them up or something like that. So they are incompressible. Liquids, yeah, some liquids can be compressed a bit, but not to any significant extent. But gases are highly compressible. Okay, so we are done with this. Then we will look at this one, change of state. Now, even though we say matter exists as solids, liquids, and gases, you can change them from one state to the other. In other words, a solid can be changed to a liquid, and a liquid can be changed to a gas. So for purposes of this example, I'm going to use ice, which you are familiar with. If you freeze water, it turns into ice. When you bring it out and apply heat to it, or even if you don't apply heat to it, but you leave it, it absorbs heat from the environment, and that process is called melting. So it changes from this solid and then it becomes a liquid like this. If you continue heating it, the temperature would increase and then it will change into gas. Okay, just like you're cooking. When you're cooking, the water boils and then it changes to gas. So the process of changing a liquid to a gas is called evaporation. If you don't want the word evaporation, you can also use the word boil or boiling, or you can also use vaporize. Okay, the same thing. Now, if you have a gas, you can cool it and return it back. In other words, if you have a gas and you cool it, the process called condensation. It will change into a liquid. I think I mentioned this when I was talking about distillation. that when it gets into what we call the condenser, water is passed through it, and then the gas cools and becomes a liquid. And if you continue to cool a liquid, it freezes. It's called freezing, and then it goes back to the solid state. Now, it's important to understand that going from left to right, this is called heating. You are heating, or you can say energy is absorbed. Energy is absorbed, okay, from the environment, okay? And then here, heat is lost or removed, okay? So when you remove heat or when you cool it, then you go to the opposite side. Now, certain substances undergo what we call sublimation. And that's what I corrected earlier on when I started. I said instead of crystallization, we should talk about sublimation. Sublimation is the process by which you change a substance from solid directly to gas. It doesn't go through the liquid stage. So from solid directly to gas, we call the process sublimation. And if you have a gas and then you cool it rapidly, it can, I mean, certain substances, not all substances, certain substances can change from gas straight to a solid. And we call that process deposition. So this is all that we have to say about this. Now we are going to talk about what we call a practical investigation or practical investigations. Now, as part of what you'll be learning in grade 10, you'll be introduced to what we call practical investigations. Now, to understand practical investigations, you need to understand certain terms. Now, practicals or experiments are performed in physics, I mean, in physical sciences, to investigate what happens when you change something. Okay, so
Mr. D, are you still there? It looks like uh, Mr. D is not in the session. Okay, I think this is what I'm going to do. Just hold on for a moment. I'll just quickly notify say, then from there, I think he should be able to continue. I might need something like a minute or two to get him back. Okay, I think I've got an idea. I will just end it here. Then this will be part 1 of this lesson. And then I think as soon as I'm able to get hold of Sir, then it will be part 2. Okay, I'll just end it here. Say until we meet. Okay, definitely